Okay, so let's discuss about the first service that can be used for asynchronous communication, that is RabbitMQ. So RabbitMQ is basically a message broker that will help us to consume the messages asynchronously from the producer. Okay, so here let's first understand the basics of the RabbitMQ, how it works and what are the different components involved in this, and then we will look into a practical example, and then we'll discuss a real world example where it can be used, and then we'll discuss what are the drawbacks and what are the replacement for this RabbitMQ. Okay, so first regarding the architecture of RabbitMQ, here we first have the producer. So producer is the service or the server that is going to generate the message, or that is going to send the message. And the next component we have is the broker. So inside the broker we have three things. That is, the first one is an exchange and a binding and a queue. Okay, let's understand this. This is a very simple connection between these three. So to understand this, let's take an analogy of the airport. Okay, so here exchange is something that is a boarding airport, or the place from which you will take the flight. Okay, let's say exchange is a boarding airport. Let's say you are traveling from Delhi to Bangalore. Okay, so in this case Delhi is the boarding airport. So exchange is the place where first the message will be sent. Okay, so for example, let's say there is a service that is processing the orders in the Amazon. Let's say you placed an order and that is received by this server. So this server will be further sending that order message to the order exchange, let's say. Okay, so like that, here exchange is the place where the messages will be sent. Next we have the binding. Okay, so binding here is like the destination. Okay, so you are going to Delhi airport to go to the destination, that is Bangalore. Okay, so here the binding is the destination where you want to go from the current airport, right? And the next here the binding is the same, that will going to bind with the queue. Okay, let's come back to that, but before that let's understand what is the queue. So queue is the gate from where you will board your flight to Bangalore. Okay, so inside the airport when we enter, we will be assigned a gate number where we need to go and just wait to get boarded inside the flight, right? So queue is the place where the messages will get stored. Okay, so now if we connect all these three, then so exchange is the place where the messages will get arrived, and binding is the destination that will help the message to move to that gate or the queue. Okay, so messages will be arrived on the exchange, and from the exchange, with the help of binding, that is the destination, that will help us to find the queue where the messages will get stored, and from there, from the queue, the messages will be consumed by the consumer. Okay, so here there can be multiple consumers. So let's say if the order is placed, then that order message, let's say, needs to be consumed by the notification service, by the parcel service, or by the payment service. Okay, so all these are the different queues. Okay, but there will be a binding that will be binding that to some queue. So the messages will arrive on the exchange, and from the exchange, with the help of binding, let's say if the traveler wants to go to Bangalore, then he will be sent to the gate number 5. If he is going to Mumbai, he will be sent to the gate number 6, right? So these different gates are nothing but the queues, and the bindings are the destination. So I hope you are able to understand this very simple concept here. And this is how the messages will get stored in the queue in a FIFO manner, that is first in first out. Okay, and in the same way the consumer will consume that message. Okay, once the message is consumed, it will send back an acknowledgement to the broker, and the message will be removed from the queue. Okay, so if the acknowledgement is not received from the consumer, then the message is still present in the queue and it will not be removed. Only it is removed once the acknowledgement is received. Okay, so this is a basic overview of how the RabbitMQ works. Now let's look at example, real working example of how this can be set up. So for this, what I'm doing, I'll be running the RabbitMQ as a Docker container. So for that, you can use this Docker command. So for the first Docker command will pull the RabbitMQ image, and then this will going to create the container, and I'll be posting these things in this code base that I'll be putting into the GitHub, and I'll share that link in the description. And then here, this is a port through which you can access this UI of the RabbitMQ, and this is a port through which the Spring Boot application will connect to the RabbitMQ. So this application that we will be using, this service, will act as both producer and the consumer. Okay, and to access the UI, the default username and password is guest. Okay, so for that I have already run these commands, and the RabbitMQ is already running. So to access that, I can just copy this and I can just access it. So here log guest and guest. Okay, so now we have logged into the RabbitMQ console. So now here, as you can see, if I go to exchanges, there is one default exchange should be present right now. Okay, as I can see, there is no exchange present right now. So these are the exchanges which are the default or the inbuilt exchanges that are used by RabbitMQ, so we are not concerned about this. So now let's jump into the code and let's see how an exchange will be created, how a binding will be created, and how a queue will be created, and then we'll see how the messages will be sent and consumed. So here, first of all, inside the configuration, RabbitMQ config. So before that, we need to add a couple of dependencies, like the starter. This is a Spring Boot AM QP, that is for the RabbitMQ, then the starter web for creating the container and the REST APIs, and the Lombok dependency. These are the default dependencies that are needed. So this is the main dependency that the Spring provides us to integrate with the RabbitMQ. That's it, and the other are the normal dependencies that we need to add for a Spring Boot application. So coming back to the configuration, the first here in the container class. So with the at configuration annotation, we need to create a container class, and inside this we'll be creating these beans that will get instantiated once the application starts. So here the queue is nothing but the queue gets created. Okay, so this is a simple queue that is nothing but, in our analogy, the destination where the messages needs to be sent. And the exchange is with arrival, right, where the messages are sent from the producer, and that will be stored in this queue. And these two are binded with the help of the binding. So in the binding, what we are doing, binding builder.bind, and here I'm binding the queue. So this queue is representing this one, Q1. I'm binding that to the exchange, this exchange, with a binding key. That's a binding _ key _ 1. So this is a key through which I'm binding this queue and this exchange. So this is a very basic configuration or setup for the for an exchange. Okay, I hope this is very clear. First, we have created a queue, and this will create a queue. This will create an exchange, and we are binding both the queue and exchange with the binding key, that is binding _ key _ 1. Okay, so I hope this is clear. Next, we have the controller publisher. So let's first understand the producer. So here, this is a publisher I have created inside a service class, and here we are just using the RabbitMQ template, RabbitTemplate.convert and send. So here first I need to tell the destination, the arrival. Like for example, in our case, it was the Delhi airport, right? So this is nothing but an exchange 1 where will be going to board the flight. And this is a binding key that will be sending the messages to all the queues that are binded to this key. Okay, so one binding key can be connected to multiple queues. So right now this binding key is connected to the queue 1. Okay, so that's how we will be transferring the messages. So the message will be sent to this exchange, and from this it will be sent to the Q1 through this binding key, and there it will be stored until a consumer consumes it. Okay, now where is the consumer? So as I said, this application is itself acting as a consumer. So if I go to this class, so here we have the consumer with the where it is telling that it wants to consume the messages from this Q1. Okay, so where the messages will get stored, and as soon as the message is arrived, this consumer will pull that message and it will get printed over here. Okay, so first of all, what I'll do, I'll just comment this out. Okay, and I will run this application. So what will happen? Right now we'll have only the producer and the broker. We will not have the consumer. So in this way, we will be able to see a message stored in the broker. If I uncomment this and if I start the application, then this application will act as both producer and consumer. So in that case, I will not be able to see the messages stored over there, because as soon as the message will arrive, it will get consumed. Okay, so in the first scenario, we'll just comment this out and we'll just keep the producer and the broker. Okay, so I hope this is very much clear. This is where we have written the code for consumer, and this is a simple API that I have created where the message will be sending over this, where the message will arrive, and this send message will be called, that will be published to the RabbitMQ. Okay, so I hope this is clear. And by default, when we add this dependency, okay, so these application.properties are the default one where we do not need to add it explicitly. But if you want to make any changes, so then you can just uncomment this and we can change the port and the other parameters that are needed. Okay, but by default, these are the things. So that's why I have commented this. Okay, now let's start this. So before you start, make sure that the RabbitMQ is running, otherwise you will get the error because it will try to connect to the broker. So if I start this, you'll see that RabbitMQ has been started and the application is running on 8080. So here, now let's test it. So here I'm sending a simple message, publish over this API, and the message is testing the, let's change this message, MQ without consumer. Okay, so let me send this. Okay, I have received a proper 200 response, and if we look back here, you can see that message testing the RabbitMQ without consumer has been printed over here. So this has been printed from, first the consumer has received the message, the controller. So controller will be sending it to the send message, and here we have just logged that message. Okay, and then we have sent this message to the RabbitMQ. Okay, so now if we look at the RabbitMQ, and here if you can see that earlier we didn't have this last exchange, right? The moment we started the application, this exchange has been created by the Spring Boot application. And if we go inside this exchange, before that we can also see that we have a queue got created, that is Q1, and we have the exchange. If we go inside this exchange, we have different bindings. So the binding we have is this queue, and this was the binding that we created. Okay, and if we go, and if you want to see the messages that are stored right now in the queue, we need to go inside the queue. And in the queue, if we go to the get messages, and here if I do get messages, you can see that a message is sitting in this queue, that is testing the MQ without consumer. So this will get automatically consumed post we create a consumer. Okay, so now what I'll do, I'll just uncomment this consumer code and I will restart the application. Okay, so you will see that automatically that message will get consumed. Okay, so you can see message received, testing the MQ without consumer. And now if I go back and refresh this, or if I do get messages, you will see that queue is empty, right? Because that message got consumed. Or if we refresh this, and now if I do get message, you'll see that there are no messages left. I hope this simple demo was made you able to understand how the RabbitMQ is working here and how the messages are sent and received. Now if I send a message again, testing the MQ with a consumer. Okay, so if I send this, you will see that I have immediately received the message. And if I go and check the queue, I will not see any message because that was consumed immediately as soon as the message arrived in this queue. Okay, so I hope you are able to understand this. Next, let's stay and discuss a practical example where this can be used in a real world application, and then we'll see what are the drawbacks and what is the replacement for this service. Okay, so let's discuss about a real life example where RabbitMQ can be implemented. So the first example here we'll take where we'll have one queue with multiple bindings. Okay, so here that means in our example we'll have only one destination. That let's say people wants to travel from Delhi to Bangalore, and Bangalore is a destination. That is only one queue, but the people from Delhi can board the Bangalore flight from multiple gates. Gate 1, Gate 2, Gate 3, Gate 4, Gate 5. So that's nothing but different bindings we have, and through those bindings they can board only one flight to go to Bangalore. So that's the analogy which you can take here. Now where this can be used practically is for one of the example can be logistic notification service. So here let's say you placed an order. Okay, so that order's notifications will be arriving to you in this order, right? First it will be picked up, then it will be in transit, out for delivery and delivered. So so to make this sure, we should definitely have only one queue, because if we have multiple queues, let's say we have two queues, and in that case the first message arrived, that is picked up, and that will be sent to Q1, and in transit is, let's say, it's sent to Q2. And in this case the Q1 is having more messages that needs to be processed than the Q2. Then in that case what will happen, the in transit notification will arrive first to the user, and then he will get the picked up notification. So that's a bad user experience, right? Because first he should get the picked up, and then he should get the in transit. So that's possible only when we have one queue, right? So when we have one queue, first this picked up will be sent inside that queue, and then in transit will be sent inside that queue, and in the same order the notification will arrive to the user. And that's a right user experience, right? So that's we discussed about one order. So but practically there will be millions of orders that will be processed every day, right? So in that case, for all those orders, this order will be maintained for all the users. So all the users will be made sure that everyone will get these notifications in the order. Okay, so that is possible when we have one queue where multiple bindings. So we have multiple bindings for each of these different notifications. Okay, so all those different bindings will be sending that message to that queue, and from that queue the consumer will consume and process that message. So I hope you were able to understand this first scenario where we have one queue with multiple key bindings that can be used for a scenario like logistic notification service. Okay, so I hope you were able to understand this scenario. Next we have multiple queues with same binding key. Okay, so this is like people wants to go from Delhi to different destinations like Bangalore, Mumbai, and let's say Kolkata. Okay, so these are the three destinations from where the people wants to go, but at Delhi airport they need to board the flights from one gate. Okay, so there is only one gate available. From that gate they need to board the flights to all the different aircrafts going to these cities. Okay, so that's the analogy that you can take. Now we have one gate three different destinations, three different queues. Now that's possible, or that can be implemented practically for an e-commerce kind of application where an order is placed, okay, and that order message needs to be processed by multiple queues at the same time, or multiple services at the same time. For example, when an order is placed, an inventory service needs to be notified, an email service needs to be notified, right? So all of them needs to be notified at the same time. It's not like a queue. It's not here, you are not following in a queue, like first notification, first inventory, then email. It's not like that, right? So all of them wants to get the message at the same time. So that's the reason we will have one binding and we have multiple queues, so that all of them will be able to get the messages at the same time. So what will happen here? So the binding will get the message and it will push that message to all the different queues at the same time. And then that messages will be consumed by those queues by the consumer at the same time. So that's the another real world example where we'll have multiple queues, but with one binding, that is order placed, and the other different queues. Okay, so I hope you were able to understand these two practical examples that can be practically implemented for these two scenarios. Okay, so next let's discuss what are the couple of drawbacks of the RabbitMQ and what are the current replacements that can be done. Okay, so let's discuss about a couple of limitations of the RabbitMQ. So the first limitation is that it's not built for a very high throughput, right? Like Kafka, that provides us very high throughput. RabbitMQ does not provide that. It mostly can handle around 50k to 100k messages per second, but whereas Kafka handles millions of messages per second. But this does not mean that RabbitMQ is outdated. So basically both are made for different purpose. So when we need something, like when we want to stream the messages, so in that cases Kafka is beneficial, but for the cases that we just discussed, like for the logistic or the Amazon kind of application, then in such cases RabbitMQ is really helpful, and it is still used in many such enterprise applications. Okay, but Kafka serves completely different purpose. So but this is the case if we need very high throughput, then we should go with some other services or tools like Kafka. Else RabbitMQ can help us to serve our purpose. Okay, next disadvantage or the drawback or the limitations which you can see is it requires manual scaling. Unlike Kafka, if we add multiple brokers, then the partitions gets automatically scaled horizontally. But in case of RabbitMQ, we need to like create the queues and assign the keys, binding keys. And so basically we need to manually scale the queues if we add multiple brokers. Okay, so that things needs to be done manually, and that become complex when the system becomes very big, but that's not the case with the Kafka. So basically when we do not expect very high load, and when the things are within the limit, then definitely this will help. But this scaling can be a one-time process. So once it's scaled, then that will definitely help. But yeah, here we need to manually scale it, unlike Kafka. Okay, next limitation we can see here is that message oriented ordering is not guaranteed. So this is guaranteed in almost in the normal cases, but in some special cases where, for example, if requeuing is done or redelivery is needed or the consumer gets crashed, so in such cases the ordering is not guaranteed. Okay, so that's some of the error or exceptional cases. Okay, next limitation that we can see here is message size should be small. Okay, so here the size has to be limited, or it should be recommended to be below 256 KB. So we cannot process huge images or JSONs. So that's the other limitation. Then queue backlogs are problematic. What does that mean? So if consumers become slow, or if we have less consumers, then and if the message input or influx is very high, then that will be a bottleneck, because messages are stored on the disk in Kafka, in RabbitMQ. So disk input would become a major bottleneck if the queue becomes very big. Okay, so that's another limitation. So if such scenario, or if we have such condition, then Kafka will be the right choice to go with. Next, we have the limited streaming processing. That's another limitation where no messages reply, or once they are consumed, they are gone. As we saw in our demo, once the consumer has consumed the message, so it just acknowledges back the broker, and that message is removed from the queue. Okay, but that's not the case with the Kafka. So in the Kafka, by default, the messages get saved for 7 days, and we can also configure it as we needed. So that's major differences and couple of limitations of the RabbitMQ. But at the end, I just want to mention just one thing, that both the RabbitMQ and Kafka are completely developed or made for different purposes. They are used in different systems. So in all the cases, the Kafka doesn't or may not be able to replace RabbitMQ. Okay, so only in some conditions we can go with Kafka, but still many enterprise applications uses RabbitMQ. Okay, so I hope you are able to understand regarding the first service, that is the RabbitMQ for the asynchronous communication. Next, let's look at the next service that can be used in the asynchronous communication.